Hello everyone and welcome back to the next episode in this multiplayer inventory series. To start off, before we get into the fast array serialization stuff, I wanted to just do some housekeeping and just try and make this next section as seamless as possible. So there's a few issues that we have. I've reset my code just so I can go along with it with you. So make sure that when you're doing your entry functions like remove item from index, that you are setting the remaining amount equal to the quantity being passed in. But also what we want to do is select all this code and make sure that we're doing it when we have authority. Now I can't remember if this code was in the last episode or not. If not, please do add in the check to see if it implements the inventory item interface and that it can be removed from the inventory in the has authority block. And we're going to do the same for just below it here with the use item as well. We're going to do all these checks when we have authority, and if your IDE is like mine, then you can just remove and add back in that curly brace and it'll reformat it for you. So, yeah, there we go. So, use item, we're going to have a authority check if the quantity is less than or equal to 0, if the item is valid, if it can be used, and then if it can, then we attempt to use it. And all this is done under has authority. We're going to do the same thing here for use item at index. So if we select all of this stuff here and put that underneath has authority, do some housekeeping to clean it up so it's a bit more clean and easy to read. We should also, just to make it consistent with everything else we have here, if we just copy and paste this down here before we attempt to use the item at the index, we execute can be used and then do that, so that when we come to attempt to use an item at an index, we can trust that the item can be used. Okay, so use item, yes, and these are all that. Okay, let's come back up to adding an item. So all of this should be done with authority as well, and we can move this execute can be added to inventory here as well to say or it cannot be added, and there we go. Now remaining quantity is equal to quantity here, that's correct. Come down here to where we're adding an item, and just for the sake of trying to reduce the number of bugs, make sure that you're setting remaining quantity equal to the quantity being passed in rather than 0, because yeah, it can cause some issues. And finally, the last remove item, just remove all of this into the has authority block. And there we go. So remaining amount is equal to quantity, yep, and set that equal to quantity there as well. So yeah, just set these all to quantity, and yes, I believe that is everything. Okay, so we can finally get started with the actual tutorial. That took less time than expected. So, fast arrays, what are they? Why should you use them? Well, if we build this and have a look at our current system, we're using a normal T array, which you may know is just an array in Blueprint, but the actual type in C++ is called a T array. Now, when you replicate it, it replicates the entire array regardless of if you only change one element or change one structure or whatever, or you only added one item or removed one item. It does not matter, it replicates the entire array. A fast array is a lot more finicky than a, if you're not familiar with, that might be British terminology there. It's a bit more complex to use, I should say. Requires a lot more finesse. If we go to our plugin here, inventory. Now this is my second time recording this tutorial. We're going to go over well, all of this all over again. But our current inventory is here. It's just a normal structure of normal slots, and when it's replicated, it calls this array rep notify function. That will iterate through everything, and yep. This has all been covered in our previous tutorials. So, how do we make a fast array? Well, go to our libraries here, go to our F inventory slot, and as you can see, I've already added the include net/serialization Fast Array Serialiser.h, and before you add this in, be sure that you go to your build.cs for the module that you're using. For me, it's my inventory plugin.build.cs, and make sure that you include netcore as one of your public dependency modules. Now, excuse me, you'd want to inherit from public Fast Array Serialiser item for your F inventory slot, and let's have a look at what that actually is. So, if we scroll up here, we get a quite detailed, basically a tutorial, an overview of how this whole thing works. So, just have a read through that. You can provide the following functions in your structure to get notifiers before add, delete, and removes. All that lovely stuff. And as you can see, Unreal has actually provided, Epic Games, I should say, has provided us with quite a decent tutorial on how to set all this stuff up. So we have our properties here, which we have already, and we have our events or rep notify functions, or however you want to use them. So let's just copy these over to here, and we'll define these in just a moment. But first of all, we need to have an example array or a fast array serializer to pass in to our struct. So let's make one. Go to our libraries, right click, add file. You may have to go to your file explorer and do that. It depends on if you're using Rider or Visual Studio. I'm just going for the one that's easiest for me currently. F inventory array.h. Now, if we pragma once, always at the start. Now we need core minimal. We need net/serialization/fast array serializer, and we need our generator.h as well. Now we need a use struct. We can make it blueprint type, it doesn't really matter. And I really should turn the code by a little. I keep saying that every tutorial, but it's just so helpful sometimes. F fast array serializer. We need a generator body. We need. Let's go back and follow the rest of the tutorial. So you must wrap your T array in another struct that inherits from this. We must have a T array named item. So let's copy that over. And for the type, we are actually going to use F inventory slot, like that. And if we go back to here, let's see what else we need. I accidentally closed it, don't do that. Now we need to copy this and this template. So let's just copy all of this, go back to our array, highlight our end curly brace, and paste it back in. Copy our inventory slot over to where it says example entry, and copy our F inventory array and paste it wherever we see example array. And that should pretty much do it. Let's get rid of those. Declare a U property. You must call 30, make array 30, do rep lifetime, and that's about it. So let's come to our inventory component base. Let's go down to the bottom of the protected section. Yep. And let's make a new U property. Edit anywhere, blueprint read write, category equals inventory, yeah, sure. And we need to say f inventory array, inventory. And we need to make sure this replicates as well, don't forget that. We don't need a rep notify for this, but what we do need to do is, I'm going to put mine underneath gameplay. We need to call virtual void get lifetime replicated props, just as you see it on screen. Define it. I don't know why it does that. And do rep lifetime. You can do rep lifetime all in caps, and the name of the class and the inventory that we'll be using. Now we need to actually initialize this inventory. So why don't we do on pick and play, if the owner has authority, then we init with an inventory size, and we have an empty slot here. Now inventory size is going to be a field that is going to be an integer, and it's going to be a U property, so we can actually set it up in the inspector. Okay, I do apologise if I'm going too fast, but there is a lot to cover. We're going to be converting all of our code over to C++ from Blueprint. So, yep, okay. Now if we run this, actually no, not yet, not yet. Let's go to our F inventory slot, because it's going to cause an issue if we don't define these. We also need to make sure that we define this to use F inventory array. And let's generate these definitions, and I'm just going to print out pre-rep, and I'm just going to call get debug string, and I'm going to do the same for the rest of these. This is where Copilot really shines, just doing basic boilerplate like this. And we of course need to define f string get debug string, and it's going to be printf for the item and the quantity for these two things. Yep. Now another important note to make about fast arrays is that the index on the client and the server are not guaranteed to be the same. So we should also probably keep track of our server index. So int 32 server index, and we need to initialize that on an empty slot, and we should probably include it in our debug string. Perfect. Okay, now go back to inventory component base and make sure that we go through each of these slots and set their server index. Okay. Now let's run it. And then we're going to well, start converting our code back over. If you guys just needed a brief overview of how to set up a fast array, then the rest of the tutorial is literally just going to be converting the code from Blueprint to C++ using the fast array. Oh yeah, one last thing I forgot to mention is inventory.markArray30. We need to do that as well. And if we now play this and go to our server world, we should now be able to see it. Inventory, yep. Well, I forgot one very vital thing, which is we need to set this to visible anywhere. And is this? Yeah. Okay, perfect. Can we play this? I'll come back once this is finished loading up. Okay, so we've opened it back up. Let's play it. And now let's go to our server world again. Go to our player controller, inventory, and now we have items here. Now the reason why if you haven't got any items, is because we haven't actually set the max servers, their max inventory slots. So let's go to our class defaults here and set our inventory size to 5. Compile, save, and let's go back. And as you can see here, we've got a post replicated add for all of the new slots that we've made. Perfect. Now, let's open up our inventory component once again, and let's begin with adding items. So let's open this up. As I previously mentioned, I have gone through and done this tutorial before, but it took way too long. So many bugs. That's why I went through the bug checklist at the start of this episode. So let's start with the isValid check, setting the overflow, and all this other good stuff. We can get rid of these two now, and all of this. Let's just focus on the inventory component base. So go all the way to the top, and attempt to add item implementation. Now let's begin with checking if the item is valid. We're doing all that stuff here, but it doesn't hurt to check again. I trust the compiler a lot more than I trust myself. So I'm checking if the item is valid or the quantity is less than 0, then return false. Now we know that the verification's passed. Now we can set we'll set remaining amount at the top equal to quantity, and now we'll set stack size. So we'll get a const int, so get stack size equal to inventory item interface execute get max stack size. Now we're going to do a static assertion to make sure that this has been set up correctly. We could do some for the other ones, but this is the main one. This is going to tell us if we've set up the item correctly, if we've missed an item, etc, etc. So I'm going to type in an if, not, and then this is going to be our assertion. Ensure always message f that stack size is greater than 0, and if it fails this, then item of s has a stack size of that, which we're going to put in here as stack size. Then we're going to return false. Now, yeah, that's going to ensure that we've set up our item correctly, that the stack size for that item is greater than 1. We could add in some more checks above here, like for example, we could say instead of returning false if the item is invalid, we could do something called a check f to check if the item is not valid, or we could do something called a verify. Is it verify? Is it? Yeah, verify. To say if it is valid, which is another static assertion family. So actually, I should stop saying static assertions because I'm not entirely sure it's static, but it's definitely an assertion. Different languages and different engines are going to have different names for this sort of thing. Some engines are going to call it ensure, check, verify. So we're going to say, I don't know what Unity uses actually, at the top of my head. I just know they have different names and different engines, and you just need to keep them in mind. Check will crash the engine. Ensure will, well, it will ensure that something's right, true, something's worked or not, but it won't crash the engine. It will just instead report back to the crash manager and will print in the log a nice stack trace for you to choose from, which is nice. Okay, so we've got that. Let's have a look here. We need to check if it's greater than 1. If it's greater than 1, then do the for loop. If it's not, then we do the while loop. And okay, so we should probably sort the while loop out first. So remaining amount greater than 0, and get free slot. Well, we want to check if it's still a valid index rather than greater than 1 or 0, -1 rather, sorry. So inventory.items.is valid index, and that will check that. So const int 32 free slots equal to that. Then we need to retrieve the slot at that index. We then need to set the item and the quantity equal to the remaining amount and the stack size, as we have down here, minimum between the remaining amount and the stack size. And then we take away the remaining amount from that slot that we just set. We then need to set inventory.items at that slot equal to there. So we'll actually make that a copy rather than a reference. And now we need to mark that slot as dirty. So inventory.mark item dirty, and we will just get this and copy that. So inventory.items at the free slot is now dirty, and it'll just repeat that over and over again. Let's go for if the stack size is greater than 1. So we need to do a for loop, which is going to be int I equal to 0, I is less than inventory.items.num. I iterates, increments, I keep saying it iterates, it's similar enough. You know what I'm talking about, you know what I'm trying to say. Okay, so we need to check if it's the same item and the stack size and quantity. Yep, so we'll actually cache the slot as a copy. We'll check if slot.item is equal to item and slot.quantity is less than stack size. So if it's the same item and there's room space left at stuff, essentially. There's no point in doing this whole operation here if there's no space left. So now we need to set the delta, so we'll int 32 delta equal to slot.quantity. Then we'll set the quantity equal to the minimum between the current quantity and the remaining amount and the stack size, and then slot minus the quantity, and then there we go. So it's always the wrong way around. I mean, I know the operation is the same either way. Like, it doesn't matter which way around it is, but this look just makes more sense to me. Delta minus, yes. Delta minus, yep. Yes. Slot quantity minus delta. So we have 5 items being added. Stack size is 3. Current slot is 2. Delta is going to be set to 2. And then the remaining amount is going to be 5 minus 3 minus 2. So that's going to be 1. Which makes sense. Yeah. Give it. And then set the item at the slot, then we mark that item dirty, and then we check if it's less than or equal to 0, and if it is, then return true. And that is essentially our add item to inventory function complete in C++ and with our fast array. Actually, no, we need to return one last time. Remaining amount less than or equal to 0. And that should be it. Let's test this out, see if it's working as intended. Is there anything else I'm forgetting? Oh yes, these two things here. Need to return based on our new inventory array. Otherwise, if you go to here, make sure that you disconnect all your blueprint functions to their parent. So you can do that by just simply right clicking on this, add equal to parent function, and then just connect it up like that. If you've got a executable one, then it's very simple, just same thing, add equal to parent function, connect it up, and then just connect it up to the return node. You don't need to connect it up to the main function at all. I just like keeping the main function there, so I have something to refer back to if I ever need to change this algorithm at all, or I need to experiment with certain things. It's just nice to have. Okay, so let's save this, go back to our IDE and press play again. This is complaining at me for some reason. Not all control paths return a value. Okay, we need to also return -1 in the case that, yeah. Okay, so I've still got these laid out. Let's try adding them to my inventory. Post replicated add item quantity server index. Now let's try adding some more. Quantity 2. Nice. And now it won't add anymore. Perfect. It's exactly what we want. So, go to our first person blueprint, first person character controller. I've tweaked the one key a little bit so that it's going to call both of these functions one after the other. Only if the use of the item works. I'll just give you a few seconds to do the same. Okay. So now we've got adding to the inventory sorted. Let's go back and do the rest. So collapse this down, collapse that entire region down, and let's go on to removing an item. Now, removing an item should be just as simple as that. We're not actually going to be removing the slot from the array, we're just going to be clearing it, so there's no need to mark the entire array as dirty and replicate all that stuff again. We're just going to be changing one of the elements, so it should be a lot kinder to our bandwidth. So let's begin. Let's go back to our inventory component. Remove, attempt to remove items. So we have all of this stuff that we just need to add in. Yeah, so let's begin. So attempt to remove item. What we need to do first is set remaining amount equal to the quantity. Okay, now let's do a for loop through our inventory in I equals 0, I is less than inventory. No. Okay, clear all this. I'm trying to do it from scratch with you guys typing along with you. I'm not trying to use Copilot for absolutely everything. It would make this tutorial a lot quicker, but I find the value in tutorials like this to be explaining what's actually going on and going through the code step by step rather than just looking at the code. Besides which, I don't fully trust Copilot's code sometimes, especially when it generates big blocks of code like that. So let's check if the item matches. It's probably going to end up that the code that I'm writing and the code is suggesting are exactly the same. But no, it's not. Okay. So f inventory slot going to be equal to inventory.items at that index. And then we're going to check if the quantity is less than or equal to our current remaining amount. And if it is, then we're going to clear the slot and then repeat again. So slot dot remaining amount is going to be equal to minus equals slot dot quantity. So taking away our remaining amount, remaining amount minus slot quantity. So if we have 5 remaining items, then we take, and there's 3 items in the slot, then we're taking away 3 items from the remaining amounts. We've got 2 items left. Now we're setting it slot item equal to null pointer and the quantity to 0. Now we should also we'll do that after all the if statements. So inventory dot items is equal to that slot and marking that slot as dirty. If it's not that, then we will just take away slot dot quantity from the remaining amount, and remaining amount is equal to 0 now. Perfect. Okay. Server index is equal to -1. So I'll put that up like that. So it's always maintaining the server index. We should also make sure that this can't go below 0 as well. And that should be about it, I'm fairly sure. Now, we would just return it from remaining amounts less than or equal to 0. Just trying to think if there's anything else. I don't think so. Okay. So that's that functionality taken care of. We just now need to copy and paste this entire block of code here. And just go underneath where we are removing an index and just paste it in here. And instead of I, we're going to be using index. So we're going to get the item at the index. We also, before we forget anything, we need to const queue object pointer item is going to equal to getting an item at that index, and we just now simply check if that item is valid. Perfect. We should also be sure to set remaining amount equal to quantity, and I know we've done that thousands of times, but it's always just good to verify wherever you can. Wherever you don't verify is a potential way to exploit, at least in my experience, which admittedly is not exactly extensive, let's say. We do need one more utility method here, because as I mentioned, we do not have a way to determine if the index at the client is going to be the same one on the server. So we need a blueprint cosmetic function, that is blueprint pure, that is going to be getting an int 32, and it's going to be getting the server index at a particular index on the client. It's just a very nice helper function that's going to be doing this, and it's going to first check if it's a valid index, and if it is, return the server index. If not, return -1. And it's okay to keep that in line as well. What we want to do is wherever we call these server RPCs, instead of calling the index, we get server index at that particular index there, like that. And we want to do that wherever we're trying to access stuff by index. And I think the only other instance is when we're using items. So come down here, attempt to use item at index, and we're just going to get server index, like that. Okay. Now let's attempt to use an item, which actually we should probably test if our changes to the removal methods worked as intended. So let's go back to our editor, save, and go and replay it. Okay, so we have a compile error. Not all control paths return a value. So if we get to this point, then return remaining values less than 0. I'm fairly sure some of you may have caught that when you typed it out. If you did, well, congratulations. Seriously, I forgot to do that. It is about 10 o'clock where I am, but that's not a real excuse. So let's go to our first person player controller, and I'm just going to push all that stuff off for the time being, and I want to just remove something at the first index with a quantity of 1. Let's play it. So we have test item quantity of 1, server index 0, and if I press 1 it should now remove. Post replicated add remove items in none. Why is it doing that? Let's go back to here. I wonder why it could be doing that. Get item at index, because it's still using the blueprint version. Let's put it up there, and let's go back to our C++ and make sure that we're defining it properly here. What do you know? We're not. So return, if it's a valid index, return the item at that index. If it's not, return the pointer. So back to here, compile, save, just save all, just to make sure. Back to here, start. So now we're verifying that we connected the right blueprint function up to call the parent, and we verified that we've actually defined the C++ function. These are both very common errors when converting your blueprint code to C++ that you need to keep a vigilant eye on. Okay, so now let's test this. And pressing 1 to remove that item. And there we go. Pre-replicated remove. Item removes. Lovely stuff. And it's working. If I was to go up and add 2 of these items, then press 1. Pre-replicated remove, we have 2 quantities, post-replicated add, we have the same item but a different quantity at the same index, and now we have none. And if I tried to do that again, we have no items. So let's move on to using an item. This should be considerably easier. So we're just going to verify if the item is valid, if the quantity is greater than 1, if it implements, then we execute. If it can be used. If it can be used, then we execute on use, and it's going to just take in the item that we want to target, and then we just return true. And then if you can't do any of that, then return false. Okay, that's all we need to do there. Use item at index is just going to be the same thing, except we're going to get item at index, and check if that is valid. Actually, let's cache this to an object first. And if it's not valid, then return false. If the quantity is less than or equal to 0, then return false. And then if it, basically the same thing. Then if all else fails, then return false. Perfect. Okay. Okay, so let's open back up. And let's go to our first person player controller and just connect this back up like this. And just so I'm going to add a breakpoint here just to verify that this is indeed working. Compile save, down to here. So press F to add it to the inventory, press 1 to both use it and then immediately remove it at that index. So this should return true, and it's returning true, nice. Let's play. And now it's being removed. So let's have a look at our stack trace here. So post replicated that. That's nice. So it's using the item at there. Server use index, use item, and then we're calling server using item. which is the use function that we've implemented the last time, I believe. And then we're entering the removal process, so we're calling remove item index, which is here, and then post replicate add item none quantity 0 serve index 0, which is what we'd expect, which is great. So if we now go to our first person player controller here, go to our inventory component and lock it, and just expand all these out. You can see we've got the server index that matches up, and if we were to now just spam this, we've now got a full inventory, which we can see here. And if we were to go back to our first person player character, remove the breakpoint so it's not going to get interrupted, press play and it clears the slot perfectly. And if we were to press it one more time, then we shouldn't do anything at all. Item perfect. So that's fast arrays for you. Now, why would we use these? This is just the wrapping up portion here. Why would you use these over normal T arrays? Well, as you can probably see here, it's a lot neater, I would say. Being able to directly say replicate only this index or this item, or mark the entire array to be replicated. The second reason is, well, with this structure here, you can actually add in your own functions to say so that the inventory array itself is capable of adding items to it, removing items from it. But you could do that with a normal structure like this, with the array of structures. Another good reason why you should use it is for the inventory slot here. You can pass in the int array serializer, which is the inventory array. If in here you had a access or a reference to the inventory component itself, then you could access some of their functions and their properties, which is especially useful when we come down later to event delegates, because what you can do is when we add, remove or change stuff, we can call an event on the inventory component itself, so that we have a single access point for when we want to notify other classes or other objects that we've changed something with the inventory. And we can do that on the server side as well. So when we come down here on use, or rather if we go up to, let's go with when we want to add an item, such as here, at the end here, what we can do is we can also call a function here, say on item added, and then in inventory slot, when we add something here, we can also call in array serializer dot inventory dot on item added, and it will call the same function, go through the same code flow, which is invaluable when you have a listen server and a client who need the exact same code for the front end stuff like the UI, to back end stuff to notify some other systems. So it is very, very useful. With a normal T array, you'd have to iterate through all of the items to figure out what's changed, notify the inventory for every item that's changed. For this, you don't need to do that. You just need to notify the UI on just the indices that have changed, and it will do that for you, and it will save you such a massive headache in the long run. Trust me on that. Yeah, this has been fun. This is definitely a lot shorter than the last tutorial I recorded for this subject. The next episode is going to go over editor scripts, so we're finally going to be making our object class for the items. We're going to be making our assets, so that if you go to your content browser and you right click, we can make our object pop up in this asset list here, so you can go to a miscellaneous or something like that. We could also create our own custom category as well, just for the inventory system, which I think is quite cool. I might do that. But you can just go to here and right click and make, say, like a curve like this, and it'll have a class picker as well. Select the base class, select it, and it'll pop up in the inventory in the content browser, which is what the aim of that next one's going to be. It might be just as long as this episode, unfortunately. but it is quite an advanced topic, and I do think it's going to serve a lot of people very well to have just a basic understanding of how to make their own asset types. Okay, well, I hope to see you guys in that episode. If you liked it, please like, subscribe, comment down below. Any feedback is of course welcome. I am working on an addendum series. Basically any bug fixes or issues that you guys are having, any common problems, I will be addressing in that series. Yeah, any questions about fast arrays or multiplayer in general, just leave them down below as well. And thank you. I'll see you guys there.